Hi, now we look at the Common Test June 2012 paper revision, question 2. This is one of three long question type found in the Common Test. Now in this question, the circuit figure 2 given as shown has three impedances, Z1, Z2 and Z3, and information provided includes the voltage supply waveform Vs, the branch current waveform IT, I1t and I2t. Now, what are we required to find out? We want to find the Vs, I1 and I2 in phasor form, and we can use Kirchoff current law to determine the total current Is, and we want to find the impedance value Z1 in polar form, and finally we want to determine whether it is a capacitive or resistive or inductive circuit, and we want to draw the phasor diagram and so on and so forth. So how do we go about answering these type of questions? Now, in order to answer this question, the first thing we need to do is to convert the given sinusoidal waveform expression into phasor form. Right? We have V S in phasor form is equals to the VRMS values, which is the V peak over root 2 angle 0 degrees, because there is no phase shift, and that's equals to 265.17 angle 0 for I branch circuit number 1 will be I1 peak over root 2 at an angle of minus 15 degrees ampere, which is equals to 8.49 at an angle of minus 15 degree ampere. And finally I2 peak divided by root 2 at the angle of plus 20 degrees ampere, which is equals to 10.61 at the angle of plus 20 degrees ampere. Alright, so that's the phasor version in polar format of the three sinusoidal waveform that was given to us. Alright. So that's for part 1 that we want. Now for part 2, we make use of Kirchoff current law, which states that the total current in the circuit is equals to I branch 1 current plus I branch 2 current. That is Kirchoff current law, which means that if I substitute in the phasor values, I will get 8.49 at an angle of minus 15 degrees ampere plus 10.61 at an angle of 20 degrees ampere. Now this is basically a complex numbers representation, so we convert this to the rectangular form to do addition, right? That's what we should do. And that's what we are going to do. The first complex number will transform into 8.2 minus J 2.2 ampere plus 9.97 plus J 3.63 ampere. Which is equals to 18.17 plus J 1.43 ampere. Now, this gives us 18.23 at an angle of about 4.5 degrees in the polar form. Alright, previously we have calculated the total current is equals to 18.323 amps at the angle of 4.5 degrees. We next convert it back to the sinusoidal expression, which becomes IST is equals to, now we need the peak value. Peak value is the RMS value, 18.23 times root 2. To convert it back to the peak value, sine of now omega t plus a phase angle of 4.5 degrees. That's the final answer for part 2. Right, I should go further one more step to get it correct. It's 25.78. So 25.78 sine omega t plus 4.5 degrees ampere. Alright, that's part 2. Part 3, what we are asked to do is to calculate the impedance Z1. Now, to calculate impedance Z1, we saw earlier from the diagram that the voltage across impedance Z1 is Vs. The current coming in is I1. So Vs divided by I1 must be equals to impedance 1. So we use the formula Z1 is equals to Vs over I1 in phasor form. So we can use the values that we have computed earlier, 265.17 at the angle of 0 degree divided by I1, which is 8.49 at an angle of 15 degrees, but it's minus ampere. This gives me an impedance value of 31.25 at an angle of 15 degrees ohms. That's the impedance Z1. Next, part 4, we need to determine whether is the circuit resistive, inductive, or capacitive. Now, to do that, we need to compute the total impedance. Total impedance ZT will be given by the applied voltage Vs and the total current Is, which is 265.17 at an angle of 0 volt, divided by the total current which we calculated earlier, 20.23 at an angle of 4.5 degree ampere. This gives us a value of 14.55 at an angle of minus 4.5 degrees ohm. Now, based on this information, it tells me that because of the negative, and that means there is a phase shift to the left. Hence, the circuit is capacitive. Nature. Now, part 4 requires us to sketch the phasor diagram. Right? To sketch the phasor diagram, we have the vertical j-axis and the horizontal real axis. So Vs is at 0 degrees, so Vs would be drawn in horizontal direction. So Vs this is Vs with a value of 265.17 at the angle of 0 volt. Is we computed earlier, it's slightly above, so Is is something like that. Is is 18.23 at an angle of 4.5 degree. I1 will be given as, because I1 is negative 15, so I1 will be down this way, 15 degrees. I1, which is equals to 8.49 at the angle of minus 15 degrees ampere. And finally, we have the I2, which is positive 20, so I2 is going this direction with an angle of 20 degrees. I2, which is equals to 10.61 angle plus 20 degrees ampere. Right, there you are. This is the phasors and the magnitude in the angles. Okay, so this is answer to the part 5. And the last part requires us to find Z2 if given Z3. Right? If Z3 is given as J50 ohm, we want to know what is the impedance Z2. Now, how do we do that? In order to do this, we need to make use of the fact that Z2 and Z3 are in series, right? And Z2 and Z3 are in series. They are in the same branch circuit. Z2 and Z3 are in series. They are in the same branch circuit. So if I can use Vs divided by I2, should be the same as the impedance Z2 and Z3. In other words, Z2 plus Z3 is equals to the applied voltage Vs and the branch divided by the branch current I2, which we have calculated earlier. So Vs is 265.17 at an angle 0. divided by the current of branch 2, which is 10.61 angle 20 degrees, which gives us a value of 25. 25, the angle of minus 20 degree. Oops. From this equation, I can then deduce that Z2 must be equals to 25 at the angle of minus 20 degrees minus Z3. Now, since this is the subtraction, it is easier for me to convert this to the rectangular format and do the mathematics that way, right? So 25 at the angle of minus 20 can be transformed into 23.49 minus J 58.55. where Z3 is equals to J 50. This is equals to 63.09, the angle of minus 68.14 degrees. So that's the answer for part 6. .25 at the angle of minus 20 degree being equals to 23.49 minus J 8.55. 0.55